Hello, everyone, and welcome to our webinar today, Process Monitoring Tools for Winery Sanitation Programs. My name is Calvin Watkins. I'm with Gusmer Enterprises. I'm located here in Fresno, California. We have a lot to cover, so let's dive right into the webinar. So just a quick agenda. We're going to go through why we want to monitor for microbes in the winery. We're going to talk about process sanitation and what a good process sanitation program might look like. We're going to look at hot spots or problem areas, common ones in the winery. We'll look at sanitary sampling, and we'll also look at testing and monitoring using the Millipore Sigma Easy Fit devices and the MVP icon tool. If you have any questions during the webinar, please use the Q&A function in Zoom, and we will answer those questions at the end of the webinar. Real quick about Gusmer Enterprises. Our motto since 1924 has been service with knowledge. Our company was founded in 1918. The management and ownership is currently in its third generation. Our core markets and products are fermentation and filtration products and services for food, beverage, and pharmaceutical applications. We have three locations in California, a location in Waupaca, Wisconsin, and one in New Jersey, where that's our headquarters. We also have 15 direct technical sales reps throughout the United States. We sell both manufactured and resale products. We have 4 product managers, of which I'm one, 3 application specialists, and 16 R&D scientists. After the webinar, you can go to our website, www.gusmerenterprises.com, and click on the Find a Rep button to look up your local representative, your technical sales rep, to if you have any questions or if you want to discuss anything that you see in today's webinar. So, why do we want to monitor for microbes anyway? Like it or not, sorry to break it to you, but microbes are in the winery. They're definitely there, and they can cause product spoilage. So they're prevalent, and we can't get rid of them. But by monitoring, we can prevent contamination and spoilage of the finished product. And if there is a contamination, we can determine what it is. So that's helpful. Monitoring allows us to find contamination points in the winery. It allows us to identify equipment failures or inadequate sanitation procedures. And it also helps us isolate contaminated product from the good product. Here's a quick info slide from a study done by BevTrack in Windsor. One of the highest culprits of micro in the winery is at the crush equipment, followed by infrastructure. So the building and the offices, that's second highest. So it's actually not insignificant. The building itself is a source for micro. Followed by cellar equipment, barrels, bottling, the atmosphere or the air, and water, so processed water, and we'll talk about that later. But that's an important source of micro. Some common common spoilage organisms. We have lab or lactic acid bacteria. We have lactobacillus, Enococcus, and Pediococcus. Some Enococcus are what you want when you're going through malolactic fermentation, but they can spoil the product as well. We also have acetic acid bacteria, or AAB. Acetobacter is one of those. And then the spoilage yeast, Brettanomyces, Saccharomyces, and Zygosaccharomyces. And different spoilage organisms will lead to the formation of different off flavors and aromas. So 4EP and 4EG, in my opinion, that would be Band-Aid. But to each his own. There's a lot of different descriptors for that off flavor. VA, in my opinion, is vinegar or acetic acid for the most part. Ethyl acetate, and I equate that to nail polish remover myself. So all those different off flavors can contribute to a stinky wine, and there I have the little skull above the wine fumes there. So um, it's not pleasant. Spoilage organisms can also result in re-fermentation in bottle and haze in bottle. So process sanitation. Process sanitation really reduces the unwanted microbes to at or below an acceptable level. You're not sterilizing when you're sanitizing. You're actually just greatly reducing your micro load when you do a sanitation. So cleaning will remove some contaminants. Sanitation will greatly reduce your micro load, and sterilization is that's defined as completely eliminating your microbes from the process. So there's three easy steps to winery sanitation, and that's to clean, then rinse, then sanitize. What we recommend for good sanitation is making sure all contact surfaces at the start of your process are reach 180 degrees Fahrenheit for 30 minutes, and hot water is really the best way to get there. Temperature plus time is a good way to sanitize all of your surfaces. What's great about hot water is that it's metal. The metal it'll heat up quickly. So since it's conductive, if one part of the metal gets hot, that'll spread to other parts of the piping and stuff. But really, you want to get all of your surfaces up to 180 degrees. That's kind of the key. A good alternative to hot water is 150 parts per million peracetic acid for 30 minutes. So that's a good alternative. Again, really, you want the ideal thing is to get all surfaces for 30 minutes. So time and either temperature or chemical. If the line remains down for an extended period, it really should be resanitized. Typically, if it's down 2 hours, I would go ahead and sanitize it again before starting up. As a part of a good sanitation program, regular audits should be performed to ensure the sanitation cycles are effective and they're being carried out correctly. And then you can check different points in the process by using an ATP meter, which we'll get into later, or a swab or sampler to check piping and equipment. You can do temperature checks on suspect areas. So if you think there's an area that's not coming up to temperature, you can use temperature checks. Now we have these non-contact thermometers that are pretty common, so that's one way to check. Visual inspections of hard to clean areas is another good one. And you definitely want to train your operators and make sure you have the proper procedures for a good process sanitation program. And just remember, audits are part of a good sanitation program. Audit is a 5-letter word. It's not a 4-letter word. So auditing a program is a good thing. So, part of a proper process sanitation program, you really want to create a list of sample points during or after sanitation. You want to check those using swabs or ATP, or collecting samples. And then identifying contamination points can help you create a map of where the contamination is occurring. And then the identification of those contamination points will allow you to focus on those points and implement improvements in the program. So I just wanted to talk a little bit about hotspots or problem areas in the winery. The picture to the right, some of us might be familiar with that picture, but it's a floor drain, and it's not the cleanest place in the winery. So a lot of floor drains have positive pressure or steam that come up, and can push micro up through the drain and back into the winery. And what's especially of concern is if you have, a line or sampling valve or other valves, drain valves that are located right above those floor drains. So you'll have positive pressure that pushes, steam that could be filled with micro up onto your equipment and causing contamination. So really, if you have valves or sampling valves above those kinds of drains, you definitely want to when you open your sampling valve, you want to let it flow, and then you'll take your sample afterward. You definitely want to close your valves under positive pressure. So when you close your valve, make sure you have that sanitation water coming out. Don't close them empty or dry. And these little bugs down here, I'm not sure if they're crickets or worse, but these little guys can come crawling up out of those drains too. So definitely a source for contamination. Some other sources are, when you're sanitizing, definitely want to open all your valves in the process. Again, if you open a valve and it's dry and you're sanitizing, um, the liquid is obviously not getting to that spot. So when you're sanitizing, open all valves. Make sure you have the chemical or the hot water flowing through those valves. And you want to close those valves while they're still under flow. So you want to close them when they're under positive flow. It's a leading cause of periodic micro hits. The drain placement, putting the drain right under a valve and having that valve be kind of a dead spot. So ideally, you would not have valves or sanitary samplers, above a drain, and you would make sure you close those valves under positive flow. Not sanitizing the top of containers like surge tanks and filler bowls. Those are common spots. Failure to reach temperature due to dead legs and long teas in your process. So it's tough to see whether every square or centimeter of the winery is getting the proper sanitation fluid to that spot. But it's you have a lot of piping in there, so it's easy. It's not uncommon to have dead legs, but that's we have them. We have to deal with those, but we want to do our best to make sure that our dead legs have that they get the proper sanitation fluid and that they get up to temperature. So just if you have long teas or spots in the winery where you think you're not getting the sanitation fluid there, make sure to check them, check the temperature in those spots. The outside of filling spouts. So, sometimes we don't get our sanitation on the outside. So spraying them with alcohol on the spouts, that'll work. Or you can use sanitation cups. And again, not using adequate water flow. So dead legs, water flow. Make sure you have enough water flow that you're able to reach all your valves and dead legs while maintaining a positive flow at the outlet. When you're sanitizing though, if you use filter cartridges, just make sure, be careful and take care that you're not using a high flow rate with high temperature. Especially if you're using filter cartridges, because a high pressure differential and high temperature can cause damage to polypropylene. So that's a good note there. Again, hot spots, dead legs, dead legs, dead legs. We said it a few times now. So just spots in the process that don't get the sanitation chemicals or water. Long tees, old piping, reclaim or recycle lines. Filling spouts, so you can spray the spouts and valves, or you can use sanitation cups. Drip and drain lines, gas lines, and addition lines are also spots of concern. I just wanted to really quickly touch on biofilms. So a biofilm is essentially a film of organic material, may or may not have old micro in it, but it's organic material that can kind of adhere to the inside of your tank or your pipe. Um, and over time, these biofilms can build up, and they're the cause of poorly performed or too infrequent sanitations. They're a house for micro, so micro will find a house there, multiply, and then be released from the biofilm. Again, they're typically in hard to clean areas, dead lakes, tees, uh, corner, random corner in the tank. Um, they're difficult to remove, but really the prevention of biofilms is key. You don't want them to build, because once they build, they're hard to get rid of. Processed water. So untreated water can be a major source of contamination in the winery. You can have water in spray hoses, water in a simple bottle rinser. Really, your processed water should be filtered or treated. 0.45 micron filter is acceptable for most wineries. However, there are some microbes that might grow and be present, which would not grow in wine and be a product concern. So essentially, the 0.45 is acceptable for wineries. In some other markets, 0.45 might not be good enough, but for wine micro, it's good enough. But some folks will go all the way down to 0.2 micron, and that will eliminate all microbes. Sanitary sampling, and we'll get into this in detail later on. But when you're taking a sample, you really want to open and close the valves while under positive pressure. So there's a photo there on the right. Liquid's coming out. That's a good time to close the valve. You want to use the smallest valves possible, just because larger valves have more of a potential to grow micro. You want to spray the valve outlet with alcohol and allow a second or two before collecting a sample. So you're going to open it, let positive flow, let the sample flow for a bit, and then collect your sample. You want to definitely install specially designed sanitary sampling valves, and we'll see what that looks like later on. Those are great tools to use as your sample valves. You want to use sterile containers for sample collection, and again, avoid those dead legs in the process. With that, I'd like to hand it over to Tim Sear, who is Senior Technology Specialist over at Millipore, and Tim will discuss further about sample collection in detail. So I'm happy to welcome Tim from Millipore Sigma.
Thanks, Calvin, and thanks, Gusmer, for giving us this opportunity. Guys, this isn't a real commercial presentation. This is really more about bioburden testing. My name is Tim Sear. I'm with Millipore Sigma. I've been in QC microbiology for about 20 years. Worked at an ID company, and now have worked at Millipore Sigma for about 14 years, just doing QC micro. So next slide. Great. Well, we started off with filtration for bioburden because that's mostly what you're going to be doing. You guys are making wine, beer, other beverages, and you're going to be doing membrane filtration. So what's the idea? The idea is we take our liquid and we pour it through a filter. And Calvin was showing filtration being 0.45 micron, which is the industry standard. Some people might even use a larger 0.7 micron filter. Why do we use 0.45 microns? Calvin, you had mentioned that it won't stop all organisms because some organisms are smaller. But even in that case, 0.45 is the industry standard because it's basically like a matrix. It's not a straight through pour. So when you say 0.45, think of a kitchen sponge. And the nominal pore size is 0.45, meaning nothing will be larger than that. But often the matrix of getting through that filter is so difficult that we even use it in sterility testing to capture all organisms. So it's not that they can't sneak through, because they can, but in general, it's better for bioburden because those larger pores in the filter allow the media to come up through the filter and feed the organisms better. And we have a paper that we can show that shows why that works the way that it does. So we use a membrane filtration because it's easier, it's faster. You can sample more. You can sample up to 100 mils. Some cases, you can dilute the actual product, meaning to allow it to filter better, and you still filter the entire product. And then finally, you can rinse that filter and get rid of any antimicrobial properties of your product, whether it be wine, again, beer, even if you were doing some sort of in-process buffer that was harmful for bacteria, you could remove that through rinsing and through also filtration. So at the bottom here, we've got 3 examples, and we'll go through some of these. I'm sure you're familiar with these. On the far left here is reusable funnels. And those are where you have stainless steel or plastic or glass, and you're either autoclaving or, you could be using hot water, or some people use other sanitants to clean them. And then you're using a vacuum in a hood. And then the middle is the disposable funnel and a membrane, where you're combining the disposable funnel. You're not reusing that funnel with a disposable membrane, obviously, that you put together yourself. And then the third step is really the safest, but it is the most expensive, is where you have a pre-assembled device where it's a single use, comes as one device. You filter, you take your filter off and put it on your media, and then you throw the entire housing away. Next slide. So what are we doing with filtration? Well, we're filtering the entire contents onto the filter, but here's what's something that can happen if you don't perform it the correct way. If you're adding a small volume to your filter, you can end up concentrating all the organisms and making it difficult to count. In this case, you'll want to dilute or it's called a dilution, but you're not really removing any organisms. You're not doing a serial dilution. All you're doing is diluting the overall product so that the organisms are more dispersed on the filter. And you should always be rinsing because in general, wine has some antimicrobial properties. Next slide. And this is what I had talked about earlier. You have retention versus recovery. So you're retaining with a 0.45 micron filter, and you're retaining just about everything. It really requires you to get up to a high titer of bugs to get through a 0.45 micron filter. But that media, those nutrients coming through those larger pores is what's allowed those bugs to grow better. So that's what we talk about when we talk about bioburden and membrane filtration. Retention, how well will it retain the organisms in our sample, versus recovery, how much better will my organisms grow? For an example, again, in that paper, a 0.22 micron filter is considered a sterilizing grade filter, but the media doesn't come through the pores as quickly or as easily, so the bugs don't grow as large. So those are the 2 things that we need to balance when we do membrane filtration, which is why we settle on 0.45 micron. Next slide. By the way, I don't read slides, and Calvin, awesome job. You didn't read your slides. No one likes slide reading, and we've all been doing presentations for a year now, so no one should be reading their slides. And you can have this presentation, so if, you guys can have this as a reference. So representative sample, this is a good point because oftentimes we say, okay, I might sample water, I'm going to take 1 mil. Now, is 1 mil a representative sample of my entire water system? Most likely not. So we want to do a representative sample, and that's going to be up to you. Could be up to your method. You might do 100 mils, maybe a bottle. It just depends. And then for your other sampling points, you really need to look and make sure, if you want to find it, that you're looking in the right places, that you're looking at upstream, at downstream, that you're sampling in the correct spots and in numbers so that you can really find that contamination. Because as Calvin said, when you get biofilm, it is very difficult to get rid of. The best way to get rid of biofilm is to never have a biofilm. So clean and make sure you have your sanitation really up to speed so that it's very robust. I wouldn't skimp on sanitation so that you're not always finding hot spots or hit and miss microbes that are sloughing off a biofilm. I would really make sure that you keep that sanitation program very robust. Next slide. So what do we want to do with our sample? We want to filter it immediately if we can. That way you're getting a real story. What's in your sample? What is growing? What could still be revived? Other stuff might be dead and not revivable, but it will give you the best picture. Now, if you have to hold this for 24 hours in refrigeration temperatures, if you have to do it, you have to do it. It's not ideal, but it's fine. But if you have to, then it'll slow any growth and perhaps even slow any death of organisms growing or dying. So you just kind of slow everything down. So do what you have to do. It's going to be plant to plant, depending on your needs and what lab you might use. So yeah, next slide. This is that sanitary valve that Calvin was showing, and it was really nice because he showed what it looked like being used outside of a pipe, and this is what it looks like in the pipe, and this is how it's built. And as he said, you don't want to shut the water system down and then close all your valves. You want that positive pressure because you don't want to cause any vacuum to pull any bugs out of the air. Obviously, the air in a winery is pretty dirty. You don't want to pull those bugs out of the air into your water system. Even if it was hot, bugs, I'm sure, as you know, because of the way Calvin was talking, with our hot spots and our drains and the dirty nature of winemaking with grapes and the people, I mean, you're going to have bugs that are going to make their way into the process. So just one less way is to make sure that these don't pull a negative pressure and pull that water, those bugs back into those to that valve. Next slide. This is just one example. There are others out there. Millipore Sigma has what's called a 55+ monitor. This one is on top of an Erlenmeyer flask with a vacuum flask, and you can see the vacuum being pulled on the side there. And you just pour your sample through, take that filter, and you can add some liquid media. You could put some, WL broth. You could put some endo broth if you're looking for E. coli. So that's a single-use device. That's an example of a single-use device. And the whole thing collapses to a Petri dish that's about that big. So next slide. So many of you would have manifold testing systems, and that's fine. That's great too. So we have the bottle top system, and this is the manifold system. You might have a 1, 3, or even a 6-place manifold. Some are old. We got a really great deal going on with Gusmer right now. We'll send that out to you after this presentation as far as getting a manifold for free. So look out for that. And this manifold can be used with any of your system. It can be used with rubber stoppers. It can be used with other types of filtration devices, but we obviously have our own filtration devices. So this gets set up in a hood, usually, where there's a vacuum source. There's other ways of doing that vacuum source. We have a pump that you can use. Some people have kind of a 2-pump system with 2 flasks. Our pump eliminates that, which is really nice. Other people just have old systems that have worked forever. That's fine. You might end up having some contamination issues with your manifold if you don't clean it regularly, particularly because we're looking at wine that's, again, organic material that's going to support the growth of biofilms and other bugs. So be sure you're cleaning that manifold. But we're going to connect it to our vacuum, and we see our little handles there. We're going to open it and pull our sample through, and then remove that filter and put that filter on a media of your choosing, whether it's tomato juice, again, WL, whatever you might be, Sabdex agar. And that's where you really want to have your aseptic technique. Is you want to use your forceps when you pull the filter cup off. You want to use your forceps very close to the edge and don't touch the actual filter. I know a lot of people flame that forceps, but good aseptic technique is something to pay attention to, so that you're just not introducing any contamination, external contamination that wasn't in the sample. Next slide. I like this slide. Everybody chooses something different based on cost, based on risk, based on their product. As we said in the beginning, we showed the reusable funnels, and then the middle product is a disposable funnel with a separate membrane that you put together yourself. And then on the right is the Easy Fit that is completely sterile and also put together. The whole cup and the filter are put together. It's single use. You put it on, you put your sample in, you vacuum, you take your filter off and put it on media. As we talked about aseptic technique, the red risk is how much risk? Well, if I have to make sure that I sanitize my entire reusable funnel system, that's going to be more risk. It's going to be higher risk of biofilms forming inside of your manifold because you're going to have more material. So it's not that with wine you're going to cause any any limits that are going to say, oh no, we have too much of this particular product or this particular bug. It's not that you're going to ruin an entire batch of wine. All this does is allow you to be more secure in your sample that says, yes, we know that we had X amount of bioburden or X amount of yeast and mold, and we know that it wasn't introduced from the users in the lab. Because that's always going to be a question when you come up around bioburden levels, when you come up around action or alert levels, or levels where you're wondering if something happened in your process. people will always start to question the lab. And when you're on this side of this scale with the pre-assembled disposable device, your risk is a lot lower of the analyst causing contamination. So next slide. So media, we've got different types of media that you guys use, which is selective and differential. As an example, we've got orange serum agar. That's a selective medium. And you might see, your yeast and mold grow in as these colonies, and they have particular nutrients, pH, temperature, whatever it might be, to select for those bugs. Sabdex agar is an example. It has a pH of 5.6 that selects for yeast and mold. Or you have differential. And this example is M. coli broth blue, which obviously E. coli would turn blue with a chromogenic substance. Or you might even have a fluorogenic substance. So selective and differential, or you might have selective and differential, selective or differential. And then you might have some media that is selective and differential. Next slide. And just some example of different typical bev culture media that we carry, that Gusmer carries. And there are definitely other ones that are out there. I find that people sometimes just use kind of what they made up in-house sometimes, which is interesting. So these are just different types of media that you'll find inside of the beverage testing market. Next slide. So then we take our plate, or either 55 plus monitor that turns into a little petri dish, or you're going to take your filter on your media, and then you're going to incubate that. Now for coliforms, because it is an enteric, because it does it comes from people, those are incubated at 35 plus or minus 0.5, so 34 to 36 roughly. It should actually be plus or minus 1 degree. That's a mistake. And then yeast and mold and total bacteria can be anywhere between 25 and 35. In general, we incubate yeast and molds at a cooler temperature because they tend to do better. But also, if you incubate mold at a higher temperature, you can get overgrowth very quickly. And once you get overgrowth, it's impossible to count the number of colonies because you just have hyphae growing everywhere. Has anyone ever had that agar plate where you put it in the incubator and it was humid or whatever the case, or you put it in the 35 degree and you ended up seeing mycelia starting to creep over the sides of the agar plate? So that's why we incubate at the lower temperatures for yeast and mold. And you can do the higher temperatures for total bacteria. And then the time is a day for coliforms, and then yeast and mold can take up to 3 days, sometimes even 5. Next slide. Just an example of total count. So just a heterotrophic plate count agar or standard plate count agar, just examples of what it looks like on a filter. These are just bugs, could be bacillus, could be staph, just different types of bugs that might grow, different sizes. You can see the growth rates for the size of the colonies. If you had some bacillus, those tend to grow really fast. If you have some sublethally injured organisms that are part of your biofilm, those might tend to grow slower. Sometimes we recommend testing the water using this heterotrophic plate count because it's lower in nutrients, and those sublethally injured organisms in the water system don't tend to do as well on TSA, which is a nutrient-rich medium. So you might want to use the heterotrophic plate count or even R2A to grow those sublethally injured bugs. But you can just see as a variety of types of bugs you might find on these media. Next slide. Another example I just wanted to show, M. green, yeast and mold, has a low pH, selects for acidophilic bacteria, also selective because it has chloramphenicol. So you can just see the different colonies, the yeast that are growing here on this plate. Next slide. As we talked, here's a mold overgrowth, impossible to count. If you wanted to check this at 8 hours, if you thought you had a mold problem, you could probably even see growth starting at 8 hours, even if you used a magnifying colony counter to have a look. If you do have a mold problem, it very well can overgrow things quickly. So next slide. And here's just another example. I like to show examples. Pictures are obviously worth more than words. So here's what we talked about in the beginning was the improper sample distribution. Never want to add 1 mil onto a filter. That's not a good technique. If you want to add 10 mils of your diluent, or even if you wanted to add the diluent and the sample together, never ever add 1 mil of product or 2 mils of product onto a dry filter. Think about a kitchen sponge. So when we take our kitchen sponge and we put a drop of water on it, does it come through the other side? No. There's electrostatic forces hydrophilic forces that are allowing that liquid to then be absorbed onto the filter and not filter through. And that's what can happen is you can just have that sample stick on the filter and all the organisms are there in the middle. So you want to make sure that you have a pre-wet filter. If you're having issues with either having bugs inhibited by the product, or you're having something like this where your sample distribution is too tight because you're not doing sample dilution. Next slide. Again, this is improper rinsing. This is where we didn't rinse around the edges and we had contamination here that didn't get rinsed away, and it caused some sort of like a biofilm on a filter. So next slide, please. By the way, my dog has a 100% accuracy rate with barking on these webinars. And I'm not kidding when I say it's 100%. Here's colony distortion. You see something like this? Could be two colonies growing together, or could be a hair particle like in this case. Next slide. Great. So that was bioburden. And now we want to go over hygiene testing. And I think I'm on track. I think so. Yeah, this will be pretty quick. So we have the MVP icon that's used for hygiene testing. And you guys are probably familiar with this. It's ATP testing, hygiene testing. So next slide. How do we choose where to look for with our hygiene testing? We have a HACCP plan. HACCP is Hazard Analysis Critical Control Point. So what you're doing when you're looking at a HACCP plan, you're essentially looking at your entire process and determining, like Calvin was talking about, if I have a point that's over top of a drain, that might be somewhere that's in the critical control point. Wherever you feel like there's a possibility of contamination in that facility, or a possibility where there's debris left over that could cause contamination, you want to evaluate your process and look for those points. So next slide, I think it's going to be just go ahead and go through all these. So you do your analysis, you look for your critical control points, you have your limits, which may be, X amount of ATP, and then you're going to say, if it's above our action limit, we're going to clean again and then sample again. And you want to have that all written out again, so that you don't end up where you have a biofilm or where you have a consistent contamination problem that causes product loss. If you do all this correctly up front, then you don't have to worry about product loss down the line. An ounce of prevention is a pound of cure. I know that makes me sound old, but I think that that's the best way. So go ahead, next slide. Calvin, just so you know, I've got some animations in here, so just work through them, that's fine. So you want to have this all written out. You want to have a plan so that you know where to sample, how often to sample, what your ATP level is going to be, and then what are you going to do if you are above those limits? Clean again using what sanitant? What if you have an organism that's resistant to the current sanitant? What if you just cleaned more and didn't use, let's say, 180-degree water, and you still can't get rid of these organisms? You're going to have to know what next steps to take to clean and make sure that you sanitize that area that will be effective against those organisms. So with that type of monitoring, you might do people, you might do their hands, you might do surfaces, you might do inside of pipes, you might look for specific spoilage organisms, indicator organisms like fecal coliforms. All this stuff might give you clues as to where your contamination could be coming from. Next slide. And these are just examples. Again, I like pictures. So you might say these sample points, obviously anytime we have a junction, that's a point for contamination. Anytime you have a junction, because that's where something is not sealed, obviously, and that's where you're going to have some sort of ingress, microbial ingress. So here she's swabbing the hose after the cleaning and swabbing the filtration system just to make sure that was sanitized correctly. Next slide. Here's some more pictures. So you might have this filling, and you might say, okay, I just sanitized, and I'm gonna check the filling nozzle. And here in this other kind of filling area with wine, this looks to be a little bit more clean. It's kind of protected. You might also have that filling nozzle. You might sample downstream from that filling nozzle to make sure that anything downstream also is clean. So that's what we talked about: upstream, filling, downstream. You can check any of those areas, and you should be doing that HACCP plan to make sure you know where to look. Next slide. So how do we ensure the bugs aren't masked by sanitizers? Well, we know sanitizers can inhibit, but they may not kill. So that's something you might say, okay, well, we used the sanitant, we used the peracetic acid, but it didn't quite kill it, because it's possible that it's just inhibiting it. So next slide. You just want to make sure that your ATP testing, did we go too far? Okay. So just so you know, in your media, if you're looking at your media, neutralizing those types of sanitants, that this chart just shows what works and what doesn't. Because sometimes stuff just doesn't neutralize that sanitant, and you have what's called just inhibition, not death, and then that bug will grow later on down the line. And so just so you know that, that when you have those sanitants, these compounds are what are used, and these media are what are used to neutralize those sanitants. Next slide. So what we're really doing with ATP is we're validating our cleaning method. That's really all we're doing. ATP doesn't measure down to the cell. It doesn't even measure 10 cells. What it measures, if you had to guess, it'd be about 100 CFU, roughly, and sometimes even a little higher than that. When we measure for ATP, ATP is present in every living cell. That's why if we clean and we clean away our wine and we clean away our other grape debris and we think we did a good job, we're measuring total cleanliness. That's really all it's measuring, and you're kind of validating your cleaning procedure. But you should know it is possible that bugs can be on that surface that will not show up in ATP, because it's not that sensitive. It is sensitive, it's just not that sensitive to detect sterility. Next slide. So how does this operate? This is a device that can be used in the winery. Now, again, we have one. This is ours, sold through Gusmer. There are others, not just, again, we didn't want to make this too commercial. This has a touch screen. So what you do is you can pull up your plan, or you can program your plan, and you can have a quick test so that you just do one test on the floor. So this device you take around and you run your sample, put it in, and get your reading. So this little device is a nice little portable instrument called the MVP icon. Next slide. Touch screen, just this I put in here just so simply you could see the pictures here. Pass, green, great. You're below your RLU level. Worn, meaning you're close. You may want to consider, depending on the sample, depending on the location, you may want to clean again and do another test. And then a fail. Easy enough. You're above your ATP levels. You will have to have an action plan in place to make sure that you clean that area again and sample it over again. Again, this will help eliminate any of those downstream problems of having contamination causing product spoilage. So this sampler, you can again load up your testing program. You can do a quick test, just a test on the fly in the plant. Either one is fine, and then you can download all this information as well. Next slide. As we said, we have zones of cleanliness. So there's pass, there's worn, and there's fail, but we also have RLUs as well. So there's different systems are a little bit different. Most use RLUs. So you can just see that at the top, you have too much ATP, too much material, again, whether it's organic or bugs, yeast and mold. And then we have the worn and the pass levels as well. Next slide. This just shows the device. I just put this in here because it just makes it easy. The device has in the chamber, it's dry, and you sample, and then you depress the top, and it puts the reagent down into the tube. You don't have to mix it, but you can, and you put that device, that pen, which I have one here, you put that pen into your device, and it's going to read the bottom, that swab, it's going to read the amount of ATP. What's nice is, remember we talked about neutralizing the sanitant? This has neutralizer in it to eliminate the potential interference of those chemicals. So next slide. Very simply, you take your swab out, swab in the 10 by 10, 4 by 4, and then you're going to put the swab back in, depress the plunger, it activates, you put it in the sampler, and then you read it with the MVP icon. Next slide. I wanted to throw these in there. These are just paddles with media and also a swabber. So this has the white one with the swab has buffer in it. This one, you take your sample and you can rub it on sample an area, put it in the liquid, and then you put the paddle in the liquid, and the paddle has media on it. so that you end up with that whole entire sample, your swab inside of that buffer, then gets mixed in with the media, and then you get your colonies at the bottom. You have your small colonies, shows the counting, and then the larger colonies on the right just shows the different types of colonies that you ended up on these paddles. We have total count, HPC, heterotrophic plate count, coliform, and yeast and mold. Next slide. Yeah, just go ahead and go through. So there's also swabbing that you guys probably do. You can do sponge swabbing and put that into a whirl pack with some buffer, and you can filter that as well. Your swabbing pattern, you can use these swabs for smaller areas that you can't get to with the sponge. Most people are using these types of hygiene swabs, but the swabs can get into those little places that a sponge can't get, but a sponge can also sample larger surfaces. So there's just different ways of looking at it, different types of sampling that you can do to give you more information to stop the contamination event from happening before you get product loss. Next slide. And I just wanted to point out, this could be just an easy way of looking at it. You might sample the source water for coliforms. You might look at the raw materials. You might look at the grape juice itself, looking for particular spoilage organisms. And all along the line, you might want to just look along the process to see, again, using HACCP, what part are we worried about that contamination can either grow or fill into my bottles and cause spoilage. So if we don't see any spoilage upstream, but we're starting to see spoilage in the middle, maybe there's some sort of fermentation that's going on, some sort of area in the process, some sort of part that's allowing those lactic acid bacteria to grow, that's allowing those spoilage organisms to survive. And then once they get into that wine in higher numbers, they then thrive, and you end up with the terrible vinegar bottle, which one time I got 2 in a row. And it was so gross. I almost couldn't drink wine the rest of the night. Bad luck for me. Next slide. Yeah. And then this just gives you, again, you don't have to worry about all the data here, just gives you a snapshot. So as it stands at the first chart, 99% of our ATP swabs in this particular point are below limit, which is great. It just gives you a nice snapshot to look and see how your plant hygiene's doing. And you can look at this on the computer. You can download this information, send it to people. It's all part of the software that's included. So it's just a nice dashboard. And even if you need some help setting up that dashboard, we'd be happy to help. Next slide. And that was it. I think I made it through my time, did I? Pretty close. Yeah. So we left 10 minutes for questions.
So yeah, with that, we'll bring Peter Stenfort from Gusmer in as our moderator to ask the questions for us. I believe we had a question about dead legs earlier. So just to clarify, a dead leg is really anywhere in your process that is not going to, the sanitation liquid won't reach that area. And so it doesn't get sanitized properly. And it could be, a piece of piping that once had a use and is now capped off and isn't used for anything now, but it's like a long, 3 foot, 6 foot stretch of pipe that doesn't see any sanitation.
Or a lot of times it'll be a U.
Right.
U's can be very much dead legs, or a pipe that ends up an L that comes to a dead end. That can be a nice source. You get that nice moisture in there. You can't clean it out. Think about if you were cleaning, if you had an L pipe and you were trying to spray it from one side that was open, but the other side was closed. It's impossible to get that liquid to make that corner. So there's lots of, if you think about that in terms of flow, that'll give you an idea where your dead legs might be.
Yep. Any other questions?
Hi, Kelvin and Tim. We do have a few questions coming in. The first one is, what is a sanitation cup? Where is it typically used?
So a sanitation cup is just an alternative to, it's for exterior cleaning. So if you want to, sanitize your sample valves and so forth. Otherwise, a spray bottle with the PAA or alcohol in it works just as well. But you just want to make sure you want to sanitize the outside of those places where you take samples.
The next question coming in, what is the most effective method to clean a manifold?
Yeah, I saw that. Samantha, thank you. The most effective way is to autoclave it. If you can't autoclave it, you guys are kind of, you're filtering stuff that's rather dirty, let's just call it, with organic material. And that organic material, as it builds up in that manifold, some people never clean them, and you will for sure eventually get backflow that ends up onto your filter, on the bottom side of your filter. So for you guys, you might be weekly where you take it apart, clean it with a brush, make sure that you really get in and around those corners. This particular Easy Fit manifold, you can take the whole thing apart. It's really great. But even if you have an old manifold, I'd clean it weekly. I'd autoclave it weekly if you could. If you can't autoclave it, the best way to probably use 10% bleach. Make sure you're changing the O-rings. The O-rings are a source of contamination because the O-rings will hold those bugs, a nice cozy place for them to grow. So take care of that manifold. And if you use those sanitants, then you can use autoclaving, and you won't end up with that extraneous contamination that comes from that backflow because of the organic buildup.
Next question we have, could you choose not to rinse wine samples while performing bioburden testing so that you're tracking only bugs that can survive in wine?
Hey, Neil, rinsing is totally fine because all you're doing is rinsing away the wine, and you're not obviously adding any sort of extraneous contamination, because if you have that wine as an antimicrobial, the bugs that were actually there may not grow. So that bug is surviving in that wine. It just may not be growing per se at that moment. It might take a while to grow. And as the pH or the chemistry structure of the wine changes, and I got to be honest, I don't know enough about wine microbiology to know when and how, what kind of titer requires to change that wine. But when it does, that bug that was present but not growing all of a sudden starts to flourish. And that's where you'll end up getting your lactic acid bacteria. So you can rinse just to get rid of the wine, just to see what's present, because what's present might not be what's growing. And that's that whole inhibition idea, not thriving, but not dead.
Looks like we've got one more that just popped up. You mentioned sanitizing reusable funnels. Is it generally acceptable to sanitize versus full sterilize in an autoclave?
Yeah, you guys exist in such, and I say you guys, it's the wine industry. I love the wine industry, by the way. It's I could say me is a part of you guys because my wife loves it too. Let me go back to that real quick. Can you go back to that? There it is. I got it. You're gonna have a higher level of bioburden. There's no doubt. You have a high level of organic material. You're working with dirty material. I mean, people are even putting their foot on the grapes sometimes. So you're working with a dirty material. When you're talking about sanitizing that cup, you could sanitize it. And if you end up seeing where you don't have it's not really changing it, and you sanitize it and you don't really see a difference in your bioburden, fine, no problem. I mean, you're already working with the dirty material. If you feel like you need to fully autoclave and sterilize that to make sure that you're not adding any intrinsic bioburden to your test, just to have that confidence, then I would autoclave it. But you guys kind of live in a, hey, kind of dirty's okay. We're looking to make sure that doesn't have X organism or this many organisms. It just depends on what that sanitization versus autoclaving means for the risk of contamination for your product. Meaning, if you say, oh, I ended up with 1,000 CFU because I sanitized it, but I didn't autoclave it, when normally our level would be 500. And you're just not doing a great job of sanitizing. So you can, but autoclaving is the best.
And I think that's all the questions that we have for today.
Great. Well, again, thank you all for joining us. And once again, if you have any other questions or want to reach out, please go to our website, www.gusmerenterprises.com. Click on the Find a Rep button, enter your city and state, and your local rep will pop up, and you can get a hold of us that way. So thank you.
Thanks, everybody.